It was just another spring morning, April 28th, 2025. But by mid-morning, a strange silence had spread across southwestern Europe. Trains had ground to a halt. Airports entered emergency mode. Phones stopped working. Cities across western Spain, Portugal, and parts of southern France were without power. No warning, no sirens, just darkness. As emergency services scrambled to respond and social media flooded with confusion, the question echoed from living rooms to newsrooms. What happened? Was this the start of a cyber war? A terrorist attack? Or something else? Something far more cosmic. The blackout began in western Spain and rapidly surged across national borders. Within minutes, Portugal and parts of France were also affected. This wasn't a local failure, it was systemic. Authorities initially blamed each other. Portugal pointed to Spain. Spain pointed to France. But soon, energy officials realized no internal malfunction or cyber intrusion could fully explain what had just happened. Technical analysis revealed a key anomaly. An atmospheric disturbance had interfered with the high-voltage synchronization of the European power grid. When one region's power goes out of sync, the entire network can collapse like falling dominoes. But what triggered this atmospheric disturbance? Eyes turned upward. At first, experts were skeptical, but satellite data confirmed it. A G2-class geomagnetic storm had reached Earth shortly before the blackout. Though classified as moderate, it was likely enough to disturb the ionosphere, a layer of Earth's atmosphere bombarded by solar radiation. Some engineers speculated this ionospheric disruption triggered the cascade of failures. Others warned this might just be the beginning. The Sun, after all, is ramping up activity as it approaches the peak of its 11-year solar cycle, known as the solar maximum. During this phase, solar flares and coronal mass ejections become more intense and frequent. And history has shown that when the Sun gets angry, Earth suffers. Solar flares aren't just pretty explosions in space. They're violent releases of magnetic energy from the Sun's surface. These eruptions eject charged particles at near light speeds. When aimed at Earth, they interact with our magnetic field, sometimes with destructive results. These events usually begin with sunspots, dark patches of magnetic chaos. Energy builds, twists, and eventually bursts into space. Earth's magnetosphere absorbs much of this impact. But when the flare is strong enough, it can punch through, triggering geomagnetic storms, disrupting satellites, and, as seen in 2025, possibly overwhelming entire power grids. The scary part? Solar flares are unpredictable. Some are harmless, others catastrophic. To understand what could happen, we must look to what already has. In 1859, British astronomer Richard Carrington observed a massive solar flare. Just 18 hours later, Earth was struck by what remains the most powerful solar storm in recorded history. Telegraph systems in Europe and North America erupted in sparks. Operators were shocked. Machines worked even when unplugged. Auroras lit up skies as far south as the Caribbean. Back then, society was not dependent on electricity. The storm was a marvel, not a disaster. But in today's hyper-connected world, a similar event could cripple civilization. Unlike in the 19th century, modern life relies on an uninterrupted flow of electricity, powering hospitals, internet servers, factories, satellites. It all depends on grid stability. A Carrington-scale flare today could overload transformers, fry satellite systems, and destroy digital infrastructure. Without power, water systems could fail. Food supply chains would collapse. Emergency services would go silent. In 1977, a lightning-triggered blackout in New York City lasted 25 hours. The result? Widespread looting, fires, over 4,000 arrests, and a sharp spike in crime. Now imagine the same event, but global. We are currently in solar cycle 25. And while it's been milder than some previous cycles, solar activity is expected to peak around 2025 to 2030. That means more flares, more CMEs, and more risk. Thankfully, Earth's magnetic shield still protects us. But recent observations show it's weakening, especially in the South Atlantic anomaly, a zone where satellites are already vulnerable to radiation. If a solar storm breaches these weak spots, consequences could be immediate and far-reaching. Forecasting tools are improving, but predicting the exact timing and intensity of a solar flare remains one of space science's great challenges. A major flare today would disable satellites, disrupting GPS, banking systems, and global communications. Astronauts in orbit could be exposed to lethal radiation. Electrical surges would destroy grid infrastructure, and even backup systems might fail. Data from the U.S. Department of Energy estimates a 24-hour outage could cost the U.S. over $11 billion. Globally, the loss could exceed $29 billion in a single day. It's not science fiction. It's just science. The blackout of April 28, 2025, might have been caused by a relatively minor storm, but it sent a clear signal. We are not prepared. Solar threats don't come with countdowns. They arrive in silence, disrupt without prejudice, and disappear before we even realize what happened. This event was a glimpse, a whisper from nature, reminding us that our modern world is built on an invisible thread. The sun gives life, but in moments it can also take our lights away. The blackout in Spain was not just a glitch, it was a warning. We must invest in solar forecasting, shield our infrastructure, and rethink how we prepare for cosmic threats. Because one day, the flare will be bigger, and we won't get a second chance. Thanks for watching. For more mysteries, deep dives, and science-driven stories, don't forget to like, subscribe, and stay curious.